Hello interwebs, welcome to the rebirth of Let's Build Electronics, the series where I find electronic kits and projects online and try them out. This series is going to be sponsored by JLCPCB and I'm aiming to do one of these every month. I'm going to need your help for ideas, so if you know of any cool open source projects for peripherals, widgets or sensors that involve some kind of custom PCB, tell me about them in the comments down below and I'll pick the ones that I like to try and make a video about. To kick off, I'm paying my third visit to Slime VR, the open source full body tracking system that I've already made a couple of videos about in the past. This is mainly because there's a new type of tracker that I was already making a video about, and I was about 80% done when JLC reached out to me again. So this was an easy place for me to get started while I spin up some new projects in the background. Let's teleport back by about a month to before I had my haircut, and I'll bring you up to speed. So as a quick catch up, Slime VR trackers have an ESP microcontroller and a motion sensor, and they connect to your Wi-Fi network and talk to the Slime VR software, which takes the rotational data from the motion sensor from multiple trackers strapped to your body and uses this to figure out the position of all your limbs and how they're moving. This method doesn't require lighthouses, so it works with inside-out headsets like the Quest, and the low cost per tracker makes high detail tracking very cheap versus traditional methods like the HTC Vive trackers. Today's video, however, is all about Slime NRF, or to use the community name, Smol Slimes. These are a new paradigm of DIY tracker that will work on the same principle of a microcontroller, an IMU, and a battery, but rather than using ESP microcontrollers that connect through Wi-Fi, the Smol Slime uses Nordic NRF micros. NRF is a proprietary 2.4 GHz protocol. The main advantage of it is that it's ultra low power to the tune of a couple of milliamps versus 80 milliamps from a regular slime tracker. So the principal advantage of Smol Slimes is that the tiny battery allows the tracker size to be much smaller. The power levels are so low that the microcontroller itself can handle battery charging, so we also get rid of the battery charging module here. Previous Slime VR trackers are more or less at an equilibrium, where the design can't really get any smaller because you still need to fit a half-decent battery in there. You can optimize the case and you can optimize the PCB, but you can't really make the battery any smaller. So we're at the point of diminishing returns where the actual trackers themselves aren't changing in size anymore. But with Smol Slimes, we're now in a gold rush to build a tracker that's barely bigger than a flash drive. So let's roll the intro and take a look at how these are built. This video is sponsored by JLCPCB. JLCPCB provide easy, affordable and reliable PCB and PCBA solutions, empowering electronics engineers to develop projects efficiently. Upload your Gerber files and get an instant quote in minutes. It's as simple as online shopping. With 1 to 8 layer PCBs starting at just $2, they have fast production and unbeatable prices. Their in-house production ensures quality and a quick turnaround, with PCB delivery as fast as 24 hours for rapid prototyping. I've used JLCPCB for several projects before they sponsored me and can personally vouch for their service. Right now, you can get a $30 coupon for JLCPCB premium 6-layer PCBs and enjoy top quality multi-layer PCBs from just $5. To learn more and discover easy, affordable and reliable PCB manufacturing, check out my affiliate links in the description below. This is aimed at both newcomers and returning Slime users who are like, I muted the Slime VR Discord for a month and suddenly the entire DIY meta has changed. Again. Meow Carrier, what is this, 2024? Now if you're thinking, wow, ESP Slime is just irrelevant now, well, sort of. Smol Slimes are very exciting and have a lot of potential, but they're also pretty immature right now, as of the writing of this video. They're using a receiver dongle instead of Wi-Fi, and this means a lower signal strength, although if your Wi-Fi router isn't in your VR room, then this might be better for you. The designs are still being figured out, and there's a whole bunch of new IMUs that people are testing. Again. And also there are some pitfalls that can result in just a hard-bricked tracker that needs the microcontroller to be replaced or completely reprogrammed. There's also still room on the table for pretty substantial changes to the firmware that might result in tracker schematic changes as well. All this is to say that as of the writing of this script, Smol is bleeding edge, so if you want a mature and proven design, the old ESP trackers might still be a better choice for a first-time slime builder. Smol Slime is unambiguously the future of Slime VR, but existing ESP designs, they still work great, and I don't think anyone should throw out their meow carriers unless you have specific desires that Smols will solve, such as the massive battery life or a super small form factor. So let's do a rundown of the components in my Smol Slimes. At the center, we've got an NRF 52840. This is the 10-star module, and it's fairly inexpensive in packs of 2 on AliExpress. The downside is that it reportedly has a pretty middling antenna, although we're not talking C3 Super Mini levels of bad here, just your PC needs to be in the same room as the trackers. The IMU that I'm going to be using is an ICM 45686, which has had a somewhat troubled start in the slime community, but is a very low power IMU, making it a perfect candidate for Smol Slimes. Normally we don't really care about IMU power consumption because it's irrelevant next to a Wi-Fi chip that's guzzling 80 milliamps. But when your whole tracker is aiming for a 5 milliamp average current draw, the IMU might actually be the biggest power draw in the circuit. I buy my IMUs from Kono Lab. Meyer is great and does huge amounts of R&D into IMUs for slimes and guarantees every single one of them, so you don't need to worry about DOAs. For my battery, I have this 160 milliamp hour 301730 cell. It's slightly oversized for a small slime, but there's a reason why I picked this cell, and I'll talk more about it in a moment. These are also from AliExpress, and they do have a built-in protection circuit for overcurrent and charge protection. Now, the currently leading design for Smol Slime is the stacked design, where you stack the IMU directly on top of the micro and then you put your cell next to it. This is super compact and really embodies the whole Smol idea. The catch is that they can be a little bit fiddly to make because you have to solder a reset button and either a power switch or a sleep button to it somewhere, but if you want Smol, then this is the design to make. This one basically wins. They've already min-maxed this. Now, my previous slime designs were based on the old frozen slime concept, which I miniaturized into what I call the Arctic slime. Now, I like these because they're fairly easy to make and they don't require any 3D printing, so I figured I'd try to miniaturize this again into a Smol Slime. I designed my PCB in KiCad and ordered it on JLCPCB.com. I can choose various colors and thicknesses, and 10 boards cost me just $5, with shipping from as low as a few dollars. After uploading my PCB files, I can preview how it'll look before placing the order so I know what to expect when it arrives. Now, since I'm not going to win any prizes for the smallest XY dimensions, because Stacked basically already does that, I thought I'd try for the thinnest slimes instead. So I've placed everything side by side, like this. I wanted to have at least 40mm strap loops because I would be able to use the existing straps that I have laying around, and I find that wider straps are more comfortable and stable on the body. The trackers bounce less, they don't move as much, and they don't dig in so easily. But 40mm on the length left me with a lot of space left to use up, and so this is where the larger but thinner battery comes into play. I was also left with this square in the top left of the PCB, so I made some fairly large pads for buttons and a power switch and things like that, so you should be able to theoretically use almost any kind of components that you have lying around or anything you have access to and kind of just bodge in what you need. On the revised version of this board, I'm going to add pads for a sleep button, which isn't needed when we have a power switch, but the idea of this PCB is that it kind of has everything on it as like sort of a dev PCB for, you know, testing stuff, swapping components out and trying different combinations. So the end result is this 50 by 50mm square, which is only a slight reduction from the Arctic design, and the Arctic C3 Super Mini can get even smaller than this. However, the whole thing will be a fraction of the thickness. So let's build one up and I'll show you how the firmware setup works. Now, the hardest part about this build is that this particular module is really difficult to surface mount because of just the size of the holes on it. By comparison, these IMUs have what's called castellations on the side, which makes them very easy to surface mount. So my strategy for this is going to be not to do all of them, because we only actually need 4 pins on the top right and 5 pins in the top left. So I'm just going to do 6 on each side for stability, and make sure all the corners are tacked down again for stability. So I'll start just by flowing a blob of solder onto this side here, and I'm going to put this on top, and now I'm going to use some added flux into each hole. Now, normally for this kind of hobby work I wouldn't consider flux to be necessary, but again, this is kind of a difficult solder job to make sure you actually get a good electrical connection, so I'm actually bothering here. And I'm going to linger on this hole for a really long time to make sure the heat has gone all the way down to the PCB. Cool. Now we're tacked in place, I'll do 6 holes in the top right and top left. While I'm here, I'm also going to add a little bit of extra solder onto the USB port, because these cheap Chinese modules, they never solder the anchor points on the USB ports properly, which makes them kind of vulnerable to breaking off. And if you're wondering if you could use like a hot plate for this, I believe you can. I have tried to use my mini hot plate, but I didn't have a lot of luck with it. I think that's just because my hot plate isn't particularly good. I was having trouble getting the solder to actually flow without just knocking all of the components of the module sideways, because they were flowing as well. Now, to check that those have actually soldered down properly, I'm just going to quickly buzz out some of the connections with my multimeter. I can't remember where they all go, so I'm just going to make this up. There's our positive connection. Our negative connection will go over to the switch here. Yep. And serial. Excellent, first try. Now I'm going to add in a power switch and a reset button. And here is the reset button I'm going to use. Now, I use just buttons that I had laying around instead of just like buying some. So these ones don't fit properly. So I'm just going to quickly just scratch my ground plane slightly to mount one on. This is kind of why I wanted to leave like nice big pads for things, because it just means that you can just do hack jobs and use just whatever parts you've got laying around. As with previous Arctic designs, this isn't necessarily a design that I recommend people make. It's just what I find interesting. So that's our ground plane, and then the top pad is the reset button. The battery didn't end up being quite as neat as I'd hoped and dreamed, but it still just about works. What I'm going to do is I'm just going to use some double-sided tape to tape this guy down, and then I'll just cut the wires to length and solder them on. It's alive! Let's just turn that off. While I'm here, I can't remember if it's actually necessary to bridge SDO on a Smol Slime or not, so I'm just going to do it for safety. Now I'm just going to get a little bit of isopropyl alcohol and just brush off the flux residue I've left behind, and we'll be done. Hyperion Light, very similar to the Meow Carrier, 1000 mAh battery, about 10 hours runtime. Adamant IT Arctic Slime, 800 mAh battery, maybe about 6 or 7 hours runtime. Arctic NRF, 165 mAh, weeks, maybe months of runtime. And it clocks in at less than 5mm thick, or 5mm thin, as Apple would say. Fantastic. Now we've just got to do the firmware programming on it. Unfortunately, there's no nice convenient web flasher for Smol Slimes. You'll need to install some software, but there is pre-compiled firmware, so we don't have to build it ourselves. I'll place links to all the downloads I use in the description, but I strongly advise referring to the Smol Slime documentation first, as my links will likely be obsolete within seconds of me uploading the video. The minimum setup is to install Nordic NRF Connect for desktop, and from within there, you need to install the programmer and the serial terminal modules. Your interface should look like this once you've done that. The first thing we need to do is update the bootloader on our microcontroller. This step is really important. Without the correct bootloader, you may brick the microcontroller. If that happens, you would need to recover it using a serial programmer, a process that I'm absolutely not going to cover in this video. So, to update our bootloader, we first need to download Adafruit's Nice Nano bootloader. We can use whatever the latest release is. Now we connect the tracker to our computer. We need it to be in DFU mode. If the light is flashing like this, it's in run mode. Press the reset button twice quickly and the status light should start pulsing. This means it's in DFU mode, and you should have a Nice Nano drive appear on the screen. Copy the bootloader we downloaded to this drive. The moment the copy is complete, the drive will disconnect itself and the tracker will reboot with the new bootloader that we sent to it. Now we're ready to send it the Slime firmware. The Smol Slime documentation has a bunch of pre-configured files, and you should find something matching your build here. I'm using a Super Mini microcontroller and an ICM with independent clock. Sleep means the tracker will auto-sleep when it senses no movement, and it will wake if it's picked up. Switch 0 is an optional sleep button that I'm not using because I've got a physical on-off switch on my design. Just like before, we download the firmware and we put the tracker into DFU mode and then copy the file into the Nice Nano drive. Now it's ready to go, but we still need a receiver so our PC can communicate with it wirelessly. When I was ordering parts, the recommended receiver was this eByte dongle, specifically the E1045040U. But since ordering this dongle, it's been pulled from AliExpress and is kind of annoying to obtain. There are other dongles available, or you can program another Super Mini to act as a receiver, although this isn't quite as elegant as a dongle. For the purposes of this video, I'm just going to give instructions for the eByte dongle, but as always, check in with the SlimeVR Discord for whatever the currently recommended hardware is. One more time, we'll download the firmware from the documentation page. Now plug the dongle into your PC. The eByte dongle should default to DFU mode when we plug it in, and as with the Super Mini, the LED will pulse red to show us this. If it doesn't, you'll need to bust open the case to reveal these buttons. Pushing the lower left button will enter DFU mode. Next, start NRF Connect and select the Programmer module. Select your device in the top left and click Add File. Select the receiver firmware file and then click Write. Now we're done flashing firmware, we need to pair the trackers to the receiver. To start this process, we're going to put the receiver into pairing mode. Close the programmer and open Serial Terminal, and then select the receiver in the top left again. Click Connect to Port, and we'll have a serial connection to the receiver. There's a bunch of commands that we can send for status updates here, so if you want, you can try typing in a few to confirm that it's working. Try typing in info and then pressing enter to see what firmware it's running. Or you can type meow to make sure that the furries are installed. And another useful command is list, which will show what devices are paired. But right now we haven't paired anything, so there's nothing here. We'll send pair to enter pairing mode. There's no real indicator for this. The LED is supposed to flash once per second, but mine seems to do that whenever the serial console is connected anyway. However, we will see feedback as pairing occurs, so we'll know when stuff is happening. Turn on a tracker and press the reset button 3 times quickly. The LED will do a flash sequence, and if you watch the console, you should see it acknowledge that a pairing has occurred. We can go through all of the trackers one after the other until they're all paired. Then send reboot to exit pairing mode, and then close the serial terminal. One last step is to do a basic calibration of the trackers. To calibrate, I'm going to switch the tracker on and then double press the reset button. The LED will turn on solid for a few seconds, then flash and go out again. This is our basic calibration done. Repeat for each tracker, and if you have your receiver dongle connected, you should find they start appearing in the SlimeVR software. It's possible to do a 6-side calibration for greater accuracy, but I'll save that for another video. This 1-side calibration gets us to a working tracker. Okay, right, so I've put straps on all of my Smol Slime trackers now. So I've got my chest, I've got a hip, I've got my thighs on each side, and I've got ankle and feet on each side. So that's the 8-tracker setup, which in my opinion is the best all-round setup. So let's drop into VR and set them up and test them out. It's impossible to look cool while wearing a VR headset, so this is what we're dealing with. However, now I'm in and I have calibrated the trackers. As you can see, my avatar is fully calibrated now and it's moving. So if I turn my chest, we get chest movement, and this includes spine bending as well. And my hips are tracked as well, so they move independently of the chest. Thigh goes up and down, ankle moves backwards and forwards, and foot can rotate. And these work exactly the same way that normal slimes do. Let's see, how's the drift? They're a little bit drifty at the moment. That's a little bit of warm-up and a little bit of calibration. A 6-side calibration will probably iron that out, but this is where we get into the game of optimizing and just the endless fettling that kind of comes with the territory for Slime VR. However, as you can see, the actual end result is pretty impressive. You need a lot of Vive trackers to get this kind of precision on any kind of body tracking. So that's it. That's Smol Slime, everyone. It's taken me way too long to get these built, and this is literally my first time testing them. So more testing is required, and likewise, I've done a little bit of battery life checking as well, and the battery life is very difficult to quantify because people will say like, oh, weeks of battery life or months of battery life. In my experience, if you actually leave them switched on all the time, then they will actually get, a matter of days of battery life. Like I think mine will, I estimated that mine will probably do like sort of 4 days, maybe 5 days, if you just leave them turned on all the time. But the point is that if you switch them off between use and you're going to have, say, I don't know, a couple of hours in VR at a time, you will then be able to go weeks or months between actual charging. Because for hours in the game, if I've got 4 days of battery life, that's what, 96 hours? So 96 hours in game is going to equate to weeks of playtime, depending on how much you use it. Thanks once again to JLCPCB for sponsoring this video. Easy to use, affordable to make, and reliable to trust, you can always count on JLCPCB. Don't forget about their 6-layer PCB special, where you can get $30 off with a coupon and enjoy a top quality 6-layer PCB for just $5. Plus their ENIG finishes and no engineering fees for VIA in-pad technology. For more information, check out the links down in the description below. Of course, another thank you to my patrons, my Twitch subscribers, and my YouTube channel members for supporting my videos, and I'll see you next time. Bye.